Ladies and gentlemen, dear guests, very good evening. This is just a brief welcome. I would like to welcome you all on behalf of the delegation of Prague to the European Union at the Prague House tonight. We are very glad that we can host this event, another edition of the Science Café, the first one in the year 2024. And we are very glad we can participate in this event together with the main organizers, representation of the South Moravian region to the European Union, Czech Liaison Office for Education and Research, and Czech Center Brussels. So tonight's topic is Earth observation, possibilities and challenges, and I will leave further introduction of the speakers and the moderator to my colleague. We hope that you will take active part during this evening by asking questions and giving out your comments and thoughts. And afterwards, we will have a glass of wine for you. But let's have the evening started now. I will pass on the floor to my colleague from the Czech Liaison Office. Thank you and have a nice evening at the Prague House.
Thank you very much for the welcoming us here. My name is Lenka Procházková. As was already said, I am head of Czech Liaison Office for Education and Research here in Brussels. And me and my team, we are really happy that we can welcome you here in such a number in the first edition of this year. As it was already said, the topic is Earth observation. And we are really thrilled to see so many eager faces here, prepared to ask questions after the Science Café. But before we kick things off, also from my side, I would like to thank to all of our colleagues from Prague House, from Czech Center Brussels, and from the representation of South Moravia to the EU, because they are fabulous colleagues organizing this event. Now, let's give a warm welcome to our moderator of the evening, Vera Pinto. Vera is a Policy and Equality Coordinator at DG DEFIS of the European Commission, driving the development of EU space aligned with EU goals. Drawing on her expertise in political science, finance and security, among others, she promotes environmental sustainability in space activities. So, Vera, the floor is yours, and enjoy the whole evening.
Thank you very much. Good afternoon, everyone. It's a pleasure to be once again in the Science Café, and today we are going again to travel to space. And space is actually one of my favorite places to be in. It's actually my job. It is quite interesting to see the interest also in what we do in Earth observation and how space and Earth observation in particular can help us on Earth solving our problems. So today we are going to talk about Earth observation, like we already said multiple times, and indeed the investments in Earth observation in the last years are being quite significant. An example of it is Copernicus, the European Union Earth observation system, but also investments like Landsat in the US or Radasat in Canada. So of course the Earth observation systems and collecting these data about and having this eye on Earth and how it is almost like taking this vital signs of Earth. And we do know that these days with climate change and with all the events that happen around it, we know that the vital signs of Earth are not mostly spectacular these days. So we really need to pay attention and to monitor it closely. And of course, these systems are quite useful on environmental monitoring, resource management, for example, but also about disaster planning and how we respond to disasters and to extreme events that unfortunately will happen more and more. So, despite all the growing applications that we are seeing linked to space data and to space services, there are still a lot of communities that face barriers in accessing this data and using it on their behalf. And it can be because of connectivity issues or it can be even for lack of resources. So today, our two speakers will precisely talk about this. They will explain a bit about the methods and the data, how do we see Earth and from space, and how we can use this data in nature protection, in agriculture, climate change, and even for security. But we will also look at academic curricula and the skilled needs. What is there also represents an opportunity for us on Earth. And of course, we will also touch upon a very important aspect that is precisely this capacity building and this sustainable expansion of the use of this space data to communities that today they don't have the same access as we have in Europe or in the US or in other countries. So without further ado, because I'm not the one who is going to explain you all of this, but it's actually our two speakers that I will then introduce. I will start by Lucy. Lucy heads the Department of Applied Geoinformatics and Cartography at Charles University in Prague. She's an expert in monitoring vegetation using satellite data, and she also leads research projects that go from forest health, land use changes, and much, much more. She also coordinates regional networks and, of course, enjoys family time, travel, and Asian history. And then our second speaker is Petr. He's a co-owner and a space strategy manager at TLR Space Systems. He's actually an expert in leveraging space technology to tackle global challenges. And previously, he developed space applications at the Czech Academy of Science and conducted research in space technology and policy at European University Institute and the Charles University. And he has also a background in think tanks and private intelligence. So he also has a background as foreign policy analyst, and I think this will bring a very interesting perspective later on our questions and answers part. So we will, of course, hear from our speakers. You will have also the opportunity to ask questions after the presentations. So keep your thoughts, all the questions you might have, because we are also here to try to reply to them. And with no further ado, I pass the floor to Lucy.
Thank you, Vera. Good evening. It's very nice to see so many faces interested in Earth observation and space. And my part, I would like to present something about Earth observation fundamentals. I don't know how experienced is this audience, so I will go very quickly through the basics of Earth observation, and then about our academic and research activities, and what is like the most important point, I would say, it's that I will speak about something that is invisible and at the same time it's very essential. So, spatial remote sensing, Earth observation, is something that is really based on sun, on energy, and on it's something that we can see and evaluate from the distance, so remotely. And we have many possibilities, not just for image remote sensing, but we have also possibility to use some tools on the Earth's surface. What is very important, it is, of course, electromagnetic spectrum, and what is important on this is that remote sensing can see what is invisible for human eye. And this is our job, to use instruments and to see, using these instruments, these wavelengths that are special and that can be seen just to this way on the base on the remote sensing. And for example, vegetation and all objects on the Earth's surface have some special reflectance during the whole spectrum, and based on this we can have special features. We can see them using these instruments. In reality, you can see everything using RGB bands, and this is what we call really composite in true colors. And this is what is possible to see by your eyes. But what is the magic of the remote sensing is that we can also use so-called false colors, and we can use this portion of spectrum that is acquired in invisible for human eyes, invisible bands or portions of the spectrum. For example, when you see this image, there are two playgrounds. Can you estimate which one has really natural grass and which one has artificial grass? No. Yes, this is what is the limit of the human eyes. But we have so-called a false color composite. Can you assume it now? Be careful, because this is false color composite, and the red one is surprisingly natural grass, because in this combination of bands, we don't see true colors, but these false colors. So this is the magic of the Earth observation. And on these figures, you can see the small portion that is visible by human eyes and the big portion that can be visible using Earth observation. And each object reflects a special has special features, and you can describe it using so-called spectral curve. And spectral curve can distinguish objects on the Earth's surface, but not just distinguish. When we have such detailed spectral curve, we can evaluate not just what is what, but we can also evaluate the state of the object. So it is very important, and it is the magic of Earth observation. And what is important for the project about which we are going to speak, these are features of images of remote sensing data. For example, one of them is spatial resolution. You can see the same place on different images with different size of pixel. And when you go to the detail, to small pixel, it's better spatial resolution, and you can see much better the detail on the Earth's surface. Then we have spectral resolution, and it is about how much bands we have in our data. This way we can distinguish so-called multispectral and hyperspectral data. Multispectral data have just several bands, and hyperspectral data have many adjacent and very narrow bands. So we have very detailed spectral curve, and this is the feature that can tell us more about the state, health, water content, chlorophyll content, and so on. You cannot find this in multispectral data, but you have it in hyperspectral data. This is example of spectral curve that you can acquire from both types of data. And then we have also temporal resolution. We have image for the same place on the Earth's surface. We can have dense time series, we can have long time series of images, and we can also consider changes within one season, so-called phenological changes, for example, for vegetation. It's very, very important. And as for acquisition, it's very important when you plan project to select good data type according to these resolutions that I was speaking about. So you should decide between UAV, between airplane or satellite, and you also, based on this, can acquire the different type of data. We have passive or active sensing, and this gives us many different types of data that can be finally combined, and we can have much better information. So this is about the introduction into remote sensing, and now several information about education at our university, at our department. We are very much specialized on remote sensing, maybe one of most specialized university in Czechia. We have a master program and PhD program. Our bachelor programs are more general, geographical, and we have also some special open courses that we have developed, and we have also many collaborators in abroad that we can use as for exchanges, and our students have possibility to go abroad in the framework of Erasmus, and also in framework of our project collaborations, because we have also several international projects, and we also organize so-called transatlantic training that is collaboration with NASA, ESA, and it is for master and PhD students. It's organized each year. So what is very important to involve our students also into the projects during master and also PhD studies, because they are very interested, they create their thesis on the projects, and they stay with us longer. That is very nice and important for us. I have here tables how many courses we have in bachelor and master studies, and I would stress that, for example, we have course focusing on laboratory and image spectroscopy. This is all about the hyperspectral data that I mentioned, and we have a really huge amount of different courses from basics of remote sensing. Then we have courses oriented on different types of data like radar, LIDAR, and also what is very important for the students is programming, mathematics, and other subjects in geoinformatics like cartography and GIS. So we also have, you can find examples of our thesis on the link that I put here, because the thesis, it's very important part of work with our students, and we really enjoy it, because especially when they work on our projects. This is shortly about education, and I hope you will have some questions for it. And finally, some examples of our projects. We love our Krkonoše Mountains and our island of Tundra in the Central Europe, and we worked there for many years to prepare methodology for monitoring of vegetation using remote sensing. This is a very special area with rich biodiversity, but there are some problems during last years, as you may know, acid rains in the last century, and also change of management. Now it is zone without management, and what is interesting, that is supposedly even this loss of the management practices in this area could lead into the loss on biodiversity. So we try to develop methodology using UAV hyperspectral and multispectral data. We acquired data for 4 years for 4 areas, and we collaborated very much with the national park and administration and with botanists and people there. And finally, we were really able, in this spatial detail, we have pixel size 3 centimeters, and we really need to find very small changes of some grasses to evaluate if there is really the problem of biodiversity. So we developed this methodology. And another project are focusing on forests. We developed some maps showing condition of forests. For this, we use hyperspectral aerial data and also satellite data, Landsat Sentinel-2. This is also collaboration with the National Park. And finally, I would like to show you another project that we had together with Tierra Al company in Maldives. And we went to the 2 islands, Gordu and Fuldahu, last year. We were there in this time last year. And it was very nice because we collaborated with the local people and with Maldives Research Space Organization, and the goal was to evaluate problems of these beautiful islands like seagrass expansion, coral bleaching, mangroves like destruction, and also some agricultural crops and their health. So we went there with our drone and hyperspectral camera. We had finally many overflights and we acquired data. You can see flight plans and some outputs that we got. And we hope that this data will contribute to save and preserve these beautiful islands and their biodiversity, and will help also the people there, because you can see on this picture they were really happy to have us there, and we were happy to be there. And I suppose that also Petr will add something to this topic. Thank you.
Thank you, Lucy. Considering the current weather in Brussels, I think we are all eager that Petr also takes us to the Maldives. But before that, Lucy, I do have a question for you, because I retain some words that you said, that was Earth observation sees what we cannot see with our human eyes. And I think this is quite impressive, and you show us a few, even tricking our minds with the false colors. But indeed, the amount of knowledge that is accumulated, even at academic, the projects that you just went through, is quite impressive. And I was wondering how we make this knowledge transfer to companies and to the communities. Maybe you could explain a bit more in a short 1 minute. I'm the time guardian. But maybe to explain a bit about this transfer of the academic knowledge to the commercialization aspects too.
Yes, thank you for the question. This is, of course, a very important issue and not easy. I would say it's rather complicated, because academic work sometimes is really special, but we have some tools to do this. For example, just now we are working on preparation of spin-off for our department. And there are, of course, some problems because we are a small department, and these activities need rather many people. But we believe that university will help us with this. But so far, we had other possibilities, like I mentioned this collaboration, for example, with administrations of the national parks. That is very important for us because it's close to the practice, and people from national parks are nowadays really very far Many administrations own their own drones, and they are very good partners for discussion, and they know what they want from us, and we try to really be close to their needs. And there is also another tool, for example, some applied projects, like some agencies in Czechia that have special types of projects, and we really provide applied outputs that are used in different sectors. Usually, we work also with some like nature preservation organizations, but this is really strict, and we have to be close to practice. And of course, on this project, we collaborate with private companies that are from space sector, and this is a very good way how to introduce our outputs to the practice.
Thank you, Lucy. I'm sure that you also have questions for Lucy, so please hold them just a bit longer until we hear also from Pret, and then we will open the floor for all your questions, and we will try that our speakers reply to it. And with this, Pet, you have a big responsibility, because now we are hoping that you take us back to the Maldives and Earth and space. So the floor is yours. Thank you.
Thank you, Vera, and good evening, everyone. First of all, thank you for such a great turnout. It's nice to see everyone interested in Earth observation and space. On the way here, we discussed that exactly last year at this time we were in the Maldives, exactly here. But it's very nice to be here as well. Let's leave it at that. I will talk a bit about our company, what we do, and then a bit about the projects, such the one as we did in the Maldives, but in principle of what we use Earth observation for, and how we believe it can be a force for good, and can help us solve many issues. So first of all, a bit about our company. We are a satellite integrator company, so we build satellites in the Czech Republic. We build customized missions for Earth observation as well as communications for different entities, governmental or commercial. We also work on lunar missions. I'll have a few sentences about that as well. And we started just a little bit over 2 years ago, and we come a long way. We are working or finishing 3 satellites that will fly this year. We're working on 2 lunar missions, and we're developing 5 different space products. We are going to be in 3 countries, so we open a branch in Rwanda, Africa. We're opening one in Asia this year. We have 51 people this year, and some other boring numbers. But we are at the beginning, and what I would like to talk about is about our strategy and what we're trying to do as a company, which is not the numbers, but a mission that we have. And I structure our strategy into 3 different pillars. One is how we can address the main challenges here on Earth, how we can extend benefits of space and Earth observation to developing countries, and how we can sustainably expand into space as a humanity. Everything that I mentioned is kind of underlined that we are a European company. We understand that we have a sort of a geopolitical role, because we believe that Europe should be a geopolitical player, and that is also why we expand into other regions in the world. We opened a branch in Rwanda last year. There's an important aspect of us acting as a counterweight to a Chinese competition. I say it out here frankly. We also do a lot of support projects and activities in Ukraine to help them use satellites for their fight, which is our fight. So little detour here. To encourage you to do everything you can right now in your Brussels connections to help us help Ukraine win this war, because it's also our war. But I'll continue with telling you a little bit about what we do. We do not just sell satellites as a company to countries. We always try to approach countries as a partner, and it helps us a bit to be from a small country, from a small Eastern European country. We do come to African countries with less of a historical baggage, let's say. It allows us to talk to them a bit more directly. But our offer does not include just selling a satellite and leaving a country. We offer a partnership in a way that we build localized manufacturing. We help to teach students and people in those countries to be able to build the satellites and use the space data themselves. We try to teach them how to use Earth observation data to solve their specific problems and how to build specifically designed satellites to solve their specific issues. And that's kind of core of our strategy and how we try to make sure that space benefits and use of Earth observation data reaches everyone, not just those in the developed countries. So, for example, in Rwanda, we have established a bachelor program in aerospace. We're working with other universities to establish programs and trainings. We are this year starting a program where we bring space engineers in training from Rwanda to us in the Czech Republic, to Brno, so they can participate in our manufacturing of satellites directly in the Czech Republic, and then go back to our branch there and work in the branch and build satellites there. Because what countries, developing countries, are interested in is not developing aid, but helping to be able to be regular partners and competitors in a regular economy on their own. And that's what we're trying to do. Sorry, a little bit of a delay here. Oh, there we go. One of the things we're doing this year is that in Africa we're starting to build the first African satellites at the local AIT center, which is sort of a core of the infrastructure where you test, qualify, and integrate the whole satellite. These are satellites that can be used for different things, from Earth observation, for security, communications, and many other things. But I will get you to what you want to hear the most, which is the Maldives. And I think the Maldives kind of show what we can do with the hyperspectral sensing there. So as Lucy talked about, we carried out this pilot projects that we monitored different things in the Maldives with hyperspectral sensing. This year we are sending in October our own hyperspectral satellite that we will use for Rwanda, the Maldives, and other countries to provide them with hyperspectral data at a very high resolution, so they can use it and learn how to use this data. But to learn how to use Earth observation data, you have to know a lot of things about what you're doing, and you have to have some basic first knowledge. So for that we carry out hyperspectral sensing pilot project, where we take a drone and we do in situ measurements to identify the specific spectral signatures of different phenomena. Lucy talked about many of them: water content, chlorophyll content, nitrogen content, farming practices, to address the specific things and the specific crops, because you need to do this in essentially every country for every plant in order to be able to automatically detect these things from a satellite. So this is the core of how we use hyperspectral data. We have a project in Rwanda where we try to understand what farming practices they use, how much fertilizer they use, how much water they use, because farming in these countries is obviously still a core part of their economy, and it's very challenging to do. One of the simple examples I have here is these images from our project in the Maldives. As you can see on the picture on the left, you can see just regular colors what the specific palm tree field looks like, and we apply different algorithms to detect health, chlorophyll content, to identify the patches where the plants were not doing well, and you can see in the picture in the middle that you can actually see some differences there. We have another example with chlorophyll measuring. With the regular eye, you can see on the left, you don't see much of a difference, but when you use the different indices from the algorithms we run, you can tell that there is something happening there. So this is just a simple example here. Another thing that we measured in the Maldives is the seagrass, not growth, but they have actually a problem with seagrass dying off. And we try to see where the seagrass is actually dying and where the seagrass is actually growing. And if you see on the picture on the left, close to the shore, you see that there is still sort of a black band of a seagrass. But when we used a regular NDVI index, you could actually tell that this seagrass is dead, that it's actually not living there. Two other things I wanted to also mention that fit the strategy as space sustainability. We are on a path to have close to 100,000 objects in space. Right now, half of them are owned by Elon Musk, and we do not possess the means to manage this orbit and this space, this near space, effectively. What you can see over there on the left is just a small millimeter-sized ball of aluminum, and what it does to a very thick aluminum plate at the orbital speeds that we see every day. What we're trying to do with this is to develop a new laser system that is actually going to detect these objects at an unparalleled precision and help us to avoid these essentially car crashes. Here's just a picture of our satellite that's flying up this October that is going to have this new LiDAR system. It's also going to have a hyperspectral camera, as I mentioned, but this should help us sort of keep the orbit sustainable as much as possible. Last thing I'm going to mention that fits the strategy is that we're trying to make sure that we expand into space sustainably. These are our lunar missions. Where we position ourselves is lunar orbiters. We work on 4 different lunar orbiter missions with ESA and NASA. You can actually find video of one of the mission concepts on YouTube if you look up TRL Space LUGO, which is Lunar Geology Orbiter. But what we're trying to do here is to pick a good area where European small, medium companies can play an important part in the lunar economy. It is going to be the next biggest economy that we enter as a world, and we want to be part of that. And we're not doing it only for ourselves. We're also doing it with our partners in Africa, in Asia, and make sure they are part of this new journey of humanity to be part of, moving humanity outside in space. And why I say that we try to do this sustainably, what we do is that we essentially not only do Earth observation, but lunar observation. The lunar orbiters are there to find what's interesting in space on the moon, what type of resources there are. Because if we are going back to the moon, we need to go there to stay and use the local resources to not be shifting everything from Earth and have the capability to build things locally. To do that, we have to know what's up there, which we do not know. So that's just a short coverage of what we do for the moon. And maybe I'll end here and leave it up for other questions from Vera or from you guys. But thanks for your attention.
Thank you, Petr. And before we open the questions for our audience, that I do hope that they have a lot of them, because I do have a lot of them, but this is not for me to ask a lot of questions, but I will allow me to do one, Petr, if you allow me, that is precisely linked to extending these benefits of Earth observation to developing countries, because you said something that is very interesting, that is, you go there, you train them, you teach them, you work with them, but maybe you could elaborate a bit more, because indeed when we speak about sustainability, and I come from a country that unfortunately doesn't have a good record, it would be quite interesting also to understand how we can leverage on Earth observation to work together with developing countries and precisely taking these sustainability multi-sustainability aspects into account. If you could elaborate a bit more, that would be great.
So I think if we make these technologies and these practices and this knowledge accessible and available to developing countries, there's going to be a lot new things that we will also learn ourselves. If I have learned something from repeatedly going to developing countries in Asia or specifically to Africa, which is not even connected to space, it's that there's a lot more that we can learn from them that we believe. across everything, not only things like governance and many other things. For Earth observation, I think because, for example, the hyperspectral sensing, it does require you to identify the specific spectral signatures of different things locally, and it does kind of force you to, open a new book and learn another way how to detect different things. And that just increases your overall knowledge and will help you to detect them back in Europe, for example. I think that's important. And I think what else is important is that when we actually go there and understand what their problems are, we know that the solutions that maybe we see that would help them out and that we offer them are much more, let's say, Eurocentric. And they really need to have their own capability to design their own solution, to design their own satellite, and understand how to operate it in order to actually receive the benefits. And I think it's a very valuable experience. So it might be not that much. It might not be only about us learning practically how to do Earth observation better, but just going on that journey with them and understanding their perception, which is a value of itself, I think.
Indeed, I think that is also a very good starting point of the importance of different perspectives and take them on board. To jump to the questions from our audience. So I would just ask you to raise your hand because we have a person that will pass you the microphone so that we can hear your question. And so this is the moment. And I see already a very eager question popping up. That's good. So thank you. If you could just tell us your name and the question, and if it is specifically for one of the speakers or both, please.
Okay, good evening. My name is Vojta, and I think I have a question for both speakers. And the question is just a quick one. The data that you collect, is any of it publicly available? I imagine that if it's a company data, especially when it's related to what's happening in Ukraine, it's not publicly available, but maybe something that comes from the Charles University research. Thank you.
Thank you for the question. I will start. In our case, we are really open to provide data that we acquired to anyone who is interested in. So there is a lot of data, for example, for the Krkonoše Mountains. Of course, there is also that the owner, it is administration of the national park, and also other data. There are some rights, but in general, I think we can we can provide it because they would agree to provide it. But maybe the different case is with private companies and with data from Maldives.
Yeah, we are sending our hyperspectral satellite this year, and we're eager to work with anyone who's interested in exploring the ways how to use this data. It will be unique type of data. It will have, it can collect up to 30 bands at a very good spatial resolution. So we were not making publicly available, but we're open to anyone to approach us with an idea and with projects to make them available to them.
And if I may to jump and add something, the Copernicus Earth observation data is fully open and available worldwide. So there's even some very interesting websites that you can go and see how your city looks like from different, using multiple spectrums that our speakers talk, that I don't dare even to mention the technical names, but you can even see that. So it's actually quite interesting to explore. And with this said, we go to another question from our audience. I just ask really to raise the hand so that we can see. We have a question here in the beginning. Thank you.
Hello, my name is Marketa, and I have a question regarding the level of information that we can get from the remote sensing. If not now, I think that maybe it's not maybe for the satellite, but for other devices. And regarding the properties in the soil, you mentioned the nitrogen, but can we also use the remote sensing to know what other, for example, chemical substances are in the soil, or what materials like microplastic? And if yes, is it more of an answer that will say that there is something, or also an answer what is there?
Thank you for the question. I would say it's a bit complicated because these devices, sensors and radiometers don't see too deep inside the soil, but you can see everything that is on the Earth's surface. So if it is there, you can, for example, detect plastics, as you mentioned, and also other nutrients that are important, for example, for agricultural. And I would mention also other possibility, because we don't have just sensors that are carried by UAVs and all these carriers that I mentioned, but we can use different type of instruments called field or laboratory spectroradiometers. These are instruments that you can use to scan these spectral features, this spectral curve signature from some samples. So you can collect samples and you can do these measurements in the field or in a laboratory. You have cable there, optical cable, and when you point the cable on any sample, you will get one spectral signature. This is, of course, not for very extensive areas, but in connection with image data, this is very good possibility how to learn more and very quickly. You need not to do some complicated laboratory analysis. You can sometimes connect these like spectral measurements also with analysis that you can do in a laboratory. It's the case of chlorophyll, for example, but for soil, there is one big advantage, because soil and geological objects in general, they have very specific spectral features that can be used for very accurate detection. So hyperspectral data can help very much, especially in geology and pedology. It's much worse in vegetation, but for these types of surfaces, it's very good.
Thank you.
I'll maybe add one more interesting thing that you can actually measure here as well. Is we actually prepared the project for a special call by USPA to use Copernicus images and use them for projects in developing countries. So it was a very interesting call. We didn't get the projects, unfortunately, but it was aimed at measuring carbon sequestration or carbon sinking of in seagrass and in forests. So you actually can link a specific carbon characteristics to amount of carbon stored in a plant if you actually do the measurement in the lab and link it together. So that's one of the interesting things you can actually do that I think for future would be very valuable to understand, how much carbon we're storing in our forests, in our seagrass, because obviously we have a major problem there.
Indeed. And just to spell it out, the acronym EUSPA is the European Union Space Program Agency, and is actually based in Prague. And one of its main tasks is precisely to leverage or to promote the use of space data and services, so Earth observation, satellite navigation, etc., and to transform this data into applications together with research institutions and universities and companies, etc. So thank you for bringing that up. It's actually a good, I think I was on the kickoff of that demonstrator. I saw that there was a question coming up from the third row, I think. If you could just raise again your hand. Thank you very much.
Hello, my name is Roya Ayazi. I'm the Secretary General of the European Network, NEREUS, Network of European Regions using Space Technologies, and we offer regions a platform to cooperate at a European scale on the use of space, and space data is one of the priorities of the interregional cooperation. And we have also a lot of universities with whom we work, and education training is a very important topic to be really fit for the next generation, to also bring the system, the Copernicus system forward. One problem we see in all regions, and that impacts also the businesses, that it's not very easy to attract talent. A lot of regions give us feedback. We need more geoinformatics specialists. We need more Earth observation specialists. What is your point of view to attract more people to the field?
Thank you for the question. From my point of view, it's I would say we need some open sources that would be available for a wide auditorium, available online, or maybe also they should need about them, because, for example, as I mentioned, we have developed some open courses that are, in our case, focusing on time series of data and their analysis. And I see some problems that maybe still remote sensing is not so well elaborated or well known, because people sometimes don't think that it can give them such good and detailed information. And also, what is maybe problem that, for example, in our case, there are some rules which methods can be used for evaluation on some environmental features, and remote sensing is not like one possible tool that can be used according to these rules. So this should be also, it is partly a political problem to promote remote sensing, and also education. I think now it is much better. We have many international collaborations and many partners also from other universities, international projects. So I believe it's better and better, and I hope in near future we will have really more specialists and many people involved. And what is important, even if, for example, we have very difficult study program, very complicated, our students really like it, and they don't give up. And I believe this is the way that maybe really better promotion can help.
I'll also comment to that. It's very hard for us to get students, get experts. We did several things to help this. One of the things was that we helped to establish the first space engineering program in the Czech Republic, and we work very closely with that. And what we did is that students that are part of it are offered an internship at our company. It's a good paid internship. I think that's a very first important step. And next thing is that they're essential part of the company. So we structure a company by different engineering teams that work on different things, and we have a specific team called Pioneers that's made up only of the interns that are still studying, and they work on the real projects. They get the full experience of what it is actually to build things for space, and it has worked so far very well for us, because the people actually want to stay with us after they finish the degree. But it doesn't even start there. We have several programs for high schools and even elementary schools to get the people engaged, because you might think that high school students are far from the job market, but in the space industry, when a space exploration mission has a timeline of 10 to 20 years, you actually need to start working with high school students because they will be the ones actually building the spacecraft eventually. So it's all these things that as a company you have to do, I think, and without it you don't have a workforce.
Indeed, and we cannot forget that in Europe, between 48 to 59% of the space workforce is above 50 years old. So that means in the next 5 to 10 years, there will be a lot of job opportunities in our sector. And we have a question in the back, but before I pass, maybe to get a bit inspiration of the young audience that we have today and maybe bring them to the good side of the force. Could you elaborate, Petr, because I know that you have this background, strategy background. Maybe you could elaborate and give some examples on the potential economic and social benefits of using space data, just as an inspiration, in case you are looking for a new career.
I mean, everything that we do is connected to space data. I think you always say that you don't have GPS, you don't know where to go, and there's one funny anecdote that I like to say is that when they asked a Marine, U.S. Marine, if he needs internet or if he needs satellites, and he of course answers, no, I don't need it. I need my rifle to find my enemy, and then my GPS, and that's it. But I think in the developing countries, what's interesting with accessing space data and Earth observation data is that you can actually see the leapfrogging there. There are completely different problems that they have, and how they can leapfrog. For example, in Europe, we have developed a dense network of optical cables for communications. In hilly rural areas of Africa, obviously they cannot do that to have it everywhere. And quite frankly, if they do have optical cables, they lack the maps, the construction processes, which cause that many times these optical cables are simply cut by someone who's building a new house. That's just a matter of fact. So for them, having an alternative with having a satellite communications means having any type of communications. And that's the example that that society just develops further with space data and with satellites.
Thank you. Lucy, would you like to complement? You have a full possible workforce here in front of you.
Yes, I think this is really very important. As you mentioned, that you have a program for engineers, and I think in our case, we really like when students work on the projects, because they already during studies get some practical experiences, and also what is important, they get very easy job in the field of Earth observation, because we can see that there are developing many private companies, and also in state institutions there are many possibilities. So I think one big motivation is for them to see that they can get very good job very easily, even during their studies. And in our case, we really have problems to have students, PhD students, because all these sectors provide big opportunities for students, and in our PhD scholarship they cannot get such amount of money, but still the projects that we have can help. So this is the way how to sustain them, and they stay with us for longer and they get better education, and this is like feedback.
Thank you. I would just like to stress a numbers of job opportunities in the space sector. We do have a question from the back of the room. Thank you so much for your patience, and the floor is yours, please.
Good evening. My name is Tomáš Vasilček, and my question would head mainly as Petr. I found it very interesting how you mentioned the use of or the monitoring of the data on forests and their carbon storage. And this is, I think, one of the many or more examples that could be useful for private companies. I'm quite wondering if private companies can obtain this data, for example, for the assessment of their emissions and storage, if they can obtain this data easily, or if it would be very costly for them. And a bit linked to that, do you see potential for development quite large commercialized markets for these data? Thank you.
Thank you for the question. It's actually very interesting because when we looked at it and tried to see what the what the market there is for trading, data about carbon storage, it's really not developed there. Many companies are looking into it. Many financing institutions are looking into it, and it's still in sort of a developing phase, I would say. What is the challenge there is that I think there are different tools. There are different also companies that are trying to map the carbon, do the carbon mapping, but there is not a single sort of authoritative source to say how much carbon is stored in what. And I think eventually we will need to have some sort of a certification or some sort of an authoritative source of how much carbon there is. Right now, I think you can sort of put a stamp on how much carbon you stored where, but it's not validated by anyone. And I think this is still something in development to be actually financeable. But a lot of the banks that's the typical customer that's interested in this data. But I don't think actually they understand yet how this could be used, how this could be monetized. So it's a very early market, and we haven't figured it out either.
There was a question from a gentleman there and two more here. So the gentleman in the green shirt was the first one to raise the hand. If the mic is coming in your direction. And then we have one question here and another one there.
Hi, so my question is going back to the Maldives. Unfortunately, I haven't been there, but I noticed that you brought one drone with you. And I imagine Maldives are not a big piece of land. And I'm wondering, so my question is about the scalability of the scanning and monitoring of an area. Let's say I work for the government of the South Moravian region, which is on the blue banner back there, and I want to monitor some parts of land which are maybe agriculturally rich for growing wine or whatever. How long would it take to scan and monitor some bigger areas? And and does it make sense to ask for this also?
Just quickly, that's the best advertisement for why you need a satellite data, because you cannot map this much area with just a drone. What we do with the drone and with in situ mapping is that we try to understand the spectral signature and then automate it. So we just can track it with the whole satellite and apply the, say, algorithm and automatically detect it, but we need that one strip or one area where we actually fly it also with the drone and understand it better. But then obviously you cannot fly over all of this area. That's what you have satellites for.
I would have another meaning, maybe a bit. Yes, Peter is right, but we have to consider the features that I mentioned. For example, the spatial resolution from satellites. You have pixel around tens of meters, but from drone you can have really this detailed pixel in centimeters. And there are some types of drones, wing drones or VTOLs, drones with vertical takeoff and landing, wing drones that are able to scan relatively big areas. So this is very nice possibility how to get data for bigger areas. And then we have here also the airplanes that can, the pixel size is somewhere in the middle, and you can have data for big areas. But as I mentioned, each type of carrier can provide different types of data. So your research question is the basic. and you have to decide in the beginning of your project which data you would like to use.
Thank you. And now we have one question here, or two more here. So this gentleman here was the first one, please. Sorry, I go for social justice. So
Okay.
first come, first serve.
Yeah, my name is Frank Kessler. I work at the European Commission in the Director General for Regional Development. In the Czech, I'm the desk officer for the Czech Innovation Program for Small and Medium-Sized Enterprises. I'm quite frequently in contact with your Ministry of Industry and Trade. So I had many discussions about Czech aviation industry. It exists even since the 1930s. And there are about 7,000 people in the Czech Republic working in the aviation industry. And as one state secretary is always saying, the Czechs are one of the few countries in the world which can build their own airplane. So that's quite remarkable for a country of that size. Now, in our program, we support SMEs, and we have quite a variety of products. It goes from the famous Kittel syrup, also from the Liberec area, but we also have drones, a company which builds drones in Liberec. It's also an EU project. And it's used for traffic control and for fires in national parks. I know I've seen the model in Liberec area. And so I think there are some very hopeful projects, and this is something to be built upon. Now, the question for the two of you, do you know this Liberec company with a mini helicopter for the surveillance? Have you heard about this project?
I don't know also.
But I do hope that they use satellite navigation to know where the drone is.
Yeah.
So there's two questions there, that gentleman, and then the other one with the glasses in the back.
Yeah, many thanks. I wonder again about scaling up. So thinking about Copernicus and the EU, I would dream of a product where you can easily go to the web and have like a map of Europe, and you could just zoom in anywhere, and getting products about forest health, maybe water use and agriculture, and I guess everybody here in the room can think of others. But you also mentioned the need of local calibration, in situ measurements. So yeah, could you maybe just talk a bit more about where will be the limit of like Europe-wide products? Like a harmonized interpretation of the spectral results, and which kind of questions will always be limited to local measurements?
Maybe I'll start. I would say that your spectral remote sensing data will always be only as good as your, in situ data and in situ knowledge of the things. So that's something that's different in every area. Different, from our experience when we monitored banana trees in the Maldives and when we monitored banana trees in Rwanda, it feels like a completely different plant. It works differently. Obviously the amount of water and the soil is completely different. So that was like a prime example of why you just have to do a different campaigns to understand it. So that would be it for different regions. I don't know how much into the how small is the micro region where you have to when you can go with one spectral characterization and where you need to do another one. But maybe to answer the first part of your question, having this on the European level, we do have a system which is a platform. We can open it on a web page, and it is like a Google Maps, and you can zoom in anywhere, and you can either search from images from the past using not only Copernicus and Landsat data, but also commercially procured data from all the satellite imagery providers, and you can also task a satellite and buy yourself a specific image that will either look at the water content, the chlorophyll content. It can detect objects, it can detect vehicles, it can detect aircraft. It has obviously a lot of security uses, but that's a solution like this. But again, it might give you a different answer and different precision if you use it across the whole world for something. It works for standardized things like vehicles, aircraft, or standardized indexes, which in a standardized way measure chlorophyll content, but it doesn't actually give you the correct, precise answer on the specific plant. So that's the limitation, and that's why you need the calibration locally, I think.
I would add that the ground truth collection is very important and will be important always. You cannot do any space research without ground truth. And also, after your analysis, you should go back to the field and do validation. You can find many papers that work just, for example, with this time series of Copernicus data and don't use ground truth. So we cannot trust these outputs because we know very well that, for example, these projects in the Krkonoše Mountains, we had very good data collection, very detailed from UAVs. And surprisingly, in this case, multispectral data worked almost, performed almost such good like hyperspectral, but always all these results we had very good accuracies, classifications. We were able to distinguish several types of grasses, very similar grasses, but the main condition is we had botanists in our team, and they collected ground truth, and we used it for training, and then we went back to the field and went for validation, and only then you can go for final processing chain and final methodology and final automatization of the whole process.
Thank you. If I may just add a disclaimer before we go to our next question, that is that gentleman there, and then we have another question there, is that Copernicus is not a true space program. And why? Because actually Copernicus is a system that collects data from multiple sources. Satellites in situ, ground, can be even a floating device in the sea, etc. That's why it has a lot of potential. Of course, it has also its limitations, as you highlighted here, but of course, it also has a lot of potential, and this data is open and free and available, and actually you just need an internet connection to access to it. So I invite you to explore it a bit. It's actually cool when we start playing with it. I did it myself. So we have the gentleman there in that side with a question.
Yes, I'm Pinto. I'm working in DG Regio in the Commission, and I have a question related with the fact that many of the issues that you are addressing, they are very urgent, let's say. Then here the question is, eventually you already have the solution. You talk at some moment about catastrophes. Forest fires, I don't know, boats that they sink. If you can monitor in real time this information, and you could take decisions because you know where the fire is going to go because it's drier in this space, or other type of decisions, eventually, as you say, with Ukraine, then do you need, because I understand that all the process of the huge amount of data that you collect takes time, and the analytics and so on. You can build up models and so on. But do you use some kind of specific software, artificial intelligence, or do you think that this will never reach this kind of almost real-time capacity to react on what you are seeing?
Yeah, thank you for that question. It does take time to process an image on the satellite, take it, send it to the ground station, receive it, and then send it to whoever needs it. First of all, the pipeline, the processing pipeline, is usually not there in terms of the people and the institutions that need to be sending the information further. But what is also another limiting factor is that, first of all, when the satellite is passing over, it takes an image. It needs to wait for it to process it. It has a limiting processing power on board, obviously, so that's one limiting factor. And then it needs to send it to a specific ground station, which usually, if we're talking about a security satellite, it needs to be a ground station in your country or in your allied country. So that can take also a bit of a time. There are some changes in this whole pipeline. People are starting to use an inter-satellite link, so you don't have to wait to send it to your friendly ground station, but send it through something like Starlink, through other satellites to yourself. But we're still in at least several minutes before it reaches the end user. You have to also think about that the satellite passes. It takes few seconds. It's above you for very, very small amount of time. It takes a picture and sends it. So we're not at a point of having a real-time video, for example, as we would see in maybe some of the Mission Impossible movies or something like this. There are other ways that this could be reached. One of the things that we've been looking into a lot for a while is high-altitude platform systems, so things called pseudo-satellites. They're in the stratosphere, about 20 kilometers in the distance. They essentially hover, but we haven't gotten the technology up there yet, so they would stay there for a long time, but that would be a tool that would allow you constant monitoring over one area that is landlocked, that can give you a constant real-time video, but that is the technology that will allow it to do that. If you wanted to do it with satellites, you need many, many satellites. You need many, many constellations. If you're looking at a real-time video, sometimes it's cloudy and you can't do anything about it. You'll have to do a different, for example, radar picture. So satellite observation has many, many limits, obviously, and this is one of them.
You would like to add something, Lucy, or you pass this one?
I would just open once again the possibility of UAVs, but still, even in this case, you can be there when you need, but there is lack of this processing chain. We can use very advanced methods, but I think we are missing this processing line. It's not in the mode when we could use it, but I believe that in the future there will be maybe elaborated better ways.
And indeed, there's a lot of potential of space digitalization, including the use of artificial intelligence in the space sector itself. So there's a lot of potential there. And in DEFIS, we actually look at these type of things. So happy to have a conversation on that. We have a lady there. Okay, she already got the mic. This is super efficient. Thank you so much.
Thank you. My name is Audrey. Regarding the projects that you have in developing countries, what kind of activities do you have to make sure that there is a transfer of know-how, of technologies, to ensure sustainability and ownership of the use of this tool? And if you have some concrete example to help me understand, that would be great. Thank you.
So the first thing that we try to ensure that the people come back when we do the training, we do internship, is that there's a project that they have lined up that they will be working on in that country. So, for example, in Rwanda, we did the trainings on some of our satellites that we're building in the Czech Republic, but this year we're launching manufacturing of a satellite in Rwanda that they're doing the training for. So a lot of times when we come to these countries, many of them did sort of developing, they did projects to build satellites with other big spacefaring countries where they promised to teach them and teach them how to build things and how to learn. But if there's not a sustainable way of sustainable projects after this lined up, then they just go elsewhere and leave the country and get the job somewhere else. So what we're trying to do here, to have a local company that has a local ownership and that has long-term projects in terms of manufacturing satellites there, so the people can have something to come back to. And obviously in Africa, in Asia, there is a market itself to be served in those areas. I think every African country should have their own satellites to have independent, access to data. And I don't think those satellites should be manufactured in Europe or in the Western world. They should be manufactured themselves. And that's sort of the approach that we're taking. So that's why we're spending a lot of time on teaching them and making sure that the people have something to come back to.
Thank you. We have one question there, another one at the ends, and another one there, and then we will need to close due to time. So those two people flagged will need to wait a little bit more, and then that one.
Hello, thank you. My name is Christian, and I have a question specifically for Peter, I think, and it's about the security measures with the LiDAR system you installed. How do you evaluate the risk of being hit by some fast-moving object, maybe about cascading effects and catastrophic events in space that are potentially to happen rather sooner than later, I think? And what's the percentage of the computation limitations of the satellite?
Thank you very much. That's a big problem that we're facing. If you think about how we destroyed and littered our own planet, you just should think about how we littered the orbits of Earth. It's even worse. And the big problem there is that we do not see where the objects or where satellites are actually flying around the Earth. The average, the most accessible data about objects in space and satellites in space are within margin of error of hundreds of meters. So when we look at something and we see, okay, well, we computate that there might be a potential collision, we actually don't know. And when satellites are on the orbit, they regularly do collision avoidance maneuvers, but 99% of these collision avoidance maneuvers are essentially false because they don't need to do them because we just don't have the data. And with the growing amount of satellites on orbit, just Starlink itself did 50,000 collision avoidance maneuvers in 6 months. They have 4,000 satellites now. They're supposed to have 40,000 satellites. So the problem with that is that every second there will be, several collision avoidance maneuvers, which changes the whole picture, the whole dynamic. So the whole movement of 100,000 satellites on orbit is changing every second, and it makes it even nearly impossible to predict because every sensor, and we measure it from Earth, makes it have its own ground truth, kind of. They see things differently. And when you see them from a different perspective, you see them differently in terms of meters. And that can have, obviously, a devastating effect because if two objects hit, they create thousands of pieces that can hit another satellite, and you get to the so-called Kessler syndrome. So there's a limitation. There are things that also play in our favor. For example, we figured out that when you have a satellite and it will come to a close approach and potential collision with another satellite, you have several orbits prior to this close approach where you get very close to it, and it allows you to sort of look at it and determine where precisely that object is, so you know that it will hit you, it will not hit you. So that's sort of an approach and opportunity that you're taking. And also, it's the objects that are the most dangerous to your satellites are not the ones that are around you. They're the ones that are on the other side of the planet, orbiting and potentially in several orbits hitting you. So it gives you a bit of time. But what is definitely not possible is to have a sensor and our sensor and look at things and see a satellite that is approaching us, calculating that it might hit us and avoiding it. There are some functions that are being developed to have automated collision avoidance, maneuverability, but this is beyond, the speed. So because you have the opportunity to see them several orbits prior, it gives you a bit more time to sort of calculate it, etc. But I would just say that we're not managing our orbits properly. We don't have the tools yet, and we're definitely running into some sort of a problem eventually with this.
Conclusion is the Gravity movie and the collision that happens in the beginning is not so far from reality, actually, right? The part of Sandra Bullock at the end, arriving Earth and getting up and walking, that's a different story, but not the collision, not the garbage around, and not the effects that it can have. So definitely something that we need to be mindful of. There was another 2 more questions that I promised, one in the back and one here in the front. I'm just not sure where the microphone is. In the back. Okay, super. Thank you.
Hi, Sibylle Meffre from Police Network. So I just wanted to know if there were some concrete use of data space for transport to improve transport networks and perhaps traffic management.
Yeah, I think there's plenty. I mean, any Google Maps app, any navigation apps rely on that. I think there's a lot of applications being developed for rail network as well, especially in Europe, and for air traffic control. I think obviously that's another point. But maybe you can fill me in.
I can add a few things. Think about e-call regulation, for example. That uses satellite navigation, for example. Digital tachograph, everything that is linked to networks. So rail, for example, is one of them that is being also using a satellite navigation. Prague, for example, the tram system in Prague is using satellite navigation, Galileo more specifically, and that actually helped them to become more efficient. And for example, extending the life use of the trams, reducing maintenance also. So not only reduces the costs, but also prolonging their life. So this is a very concrete example in a city. Everything that you think about mobility as a service, for example, with multiple platforms, usually they also use satellite navigation for that. And if you think, for example, monitoring the roads and the condition of the roads, you can also use Earth observation to do that, for example, and that will help you also to do better your planning for it. So this is just a few examples off the top of my head, but if you want, I can point you after this to some more detailed information on what concerns mobility. And we had the final question here for the gentleman. Thank you.
Yeah, thank you very much. My name is Roman. I have 2 questions, actually. One perhaps to both of you and the second one to Peter. The first one is related to, perhaps you have already explained the importance of, calibration and validation in situ, etc. But perhaps you have noticed also, as we did in Brussels, there were farmer protests in the streets. They were not only in Brussels, they were also in a couple of other countries, including Prague. And part of the problems the farmers complained about was linked to satellite or to remote sensing and remote validation of the information the farmers are obliged to provide to the authorities, national or later on to the Commission. And the problem is that the data provided by the remote sensing were not accurate, and it was creating problems for farmers with very specific and complicated situation for them. They needed to explain that, etc., etc. So, whether you could comment on that, what perhaps from your perspectives might help in improving the reliability of these processes. And the second question is related to the garbage, to the space garbage. My question is whether there are discussions on, how to put some rules on that traffic in space, on orbit, and whether there are any thoughts regarding not only preventing the crashes, but also cleaning up the orbit, so collecting and removing the garbage. Perhaps the gravity helps a lot, but whether there is any discussion or any thoughts in that direction. Thank you.
Thank you for your question. I would start with the first one. I think this is one big problem of space data now, that still the accuracy doesn't meet the needs of some sectors or groups, and especially when we use this Copernicus data, which have pixel at the best case around 25 centimeters, and also some bands have 10 meters. This is very good. But we have also possibilities of some private companies that provide satellites. They have even much better spatial resolution, but it is expensive. So this is some message for maybe for the future, that for when like control systems and institutions really ask for from, in this case, from farmers to use the data, they need to be accurate. But I believe that the technical advances are so quick that it's just a question of time. And of course, it doesn't prevent current protests of farmers, but I believe that they will be able soon to use the data in sufficient resolution.
Thank you for mentioning that. I did not know that one of the reasons for the protest was this, so that's very interesting to me. But I'll address the later question on the space debris. It is interesting. It is an interesting problem because it is a shared commons of humanity, and we need to figure out a way how to manage it. But we have no precedent of, managing a shared commons well anywhere. So it's very hard. There are rules. There are new rules. The EU and ESA have started this zero debris policy and new rules of making sure that everyone who sends a satellite up there makes sure that it has, it follows rules, that it doesn't create another space debris, that it has a defined lifetime after which it is disposed. But the problem is that, for example, for the debris, for the small pieces, now there's no point of finding out and figuring out who are the owners of the 130 million of 1 centimeter pieces of debris up there. We can find the culprits. We can find that countries that did the anti-satellite weapons testing, recently China, recently Russia, in the past European countries as well as the United States. But that's many years ago, and you really cannot track individual pieces of debris to that. So this is a hard one. Removing space debris depends how big you mean. If you want to remove a big satellite, European Space Agency is carrying out a mission to remove a big satellite from the orbit. But those are the easy things to do. Those are the easy things to monitor. We cannot track very, very small pieces, and that's when it gets hard. There are ways to do this. For example, ground-based laser momentum transfer. There's technology to use laser to slow down the pieces of debris as they're coming on the horizon. You slow them down, which means they start falling through the atmosphere, and that's essentially how we get rid of all the space debris. Eventually, it gets to the graveyard orbit and falls through the atmosphere and burns up. That's how majority of satellites are designed to end their life. What we are finding out right now is that it's not as safe as we thought. A satellite burning up in the atmosphere releases so many, gases, acids, and very, heavily dangerous substances with which we pollute our atmosphere. And we're just finding out about this, and I would say that we will see a lot of discussions and talks about how do we actually deal with this, because that's how every single satellite is designed. And it wasn't a problem until now, when Elon Musk announced that he will need to retire a very, very small portion of all of his satellite fleet, which is hundreds of satellites that will need to burn in the atmosphere, and that's when it becomes a problem. So I would say it's we don't know yet. We need to figure out as a humanity how to regulate and manage a shared space, which we do not know how.
If I may add to that, there's also a question of intellectual property. So it means that, for example, when we are removing a satellite, you need to own the satellite. You cannot remove a satellite from someone else without having the authorization. And so this is actually, from legal and policy aspects, years of discussion. I remember that one of the most original projects I saw was a Swiss company that had a vacuum cleaner to vacuum clean space debris. So you do see a lot of creativity, but then you hit some legal aspects that are not neglectable, and sometimes it doesn't make the process deal very fast. What you just mentioned about the re-entry is usually the beautiful shooting stars that we make wishes upon. Most likely that's a satellite coming in, except in November and August when we have actually meteoritis rain, showers coming towards the atmosphere. And indeed it is a concern. There's still a lot of unknowns, as you were saying, especially on this effects on high altitudes and the re-entries. There's still a lot of unknowns. There's still a lot of opportunities also for science and for universities to develop what we call the characterization models on how we measure disease impacts and all this data. Also, what I would like to finish from my side, and then I would like a final message from our speakers to close our event today, is that pay attention to the Europa website, because the European Union is working actually in the first European Union space law that addresses precisely these concerns of sustainability, safety, and environmental aspects of the space activities. And it will be quite a mark in the history of space law and of space. And it tries precisely to address some of these concerns into the limits that is possible, of course. So stay tuned, because soon there will be more news on that. And before we close our event, I would like to pass the floor to Lucy for a final short message that you would like our audience to bring with them back home.
Thank you, Vera. My message would be that I see the great possibilities of Earth observation, remote sensing, and space sciences, mainly for the young generation. And I believe there will be many opportunities, projects, science, education, and everything will be very fast. And for example, as we mentioned, these resolutions, I believe that this will be issue on the next years, and we will be soon able to work with very detailed data.
Thank you. Petr, final message?
I'll just say that space is closer than you think. It's closer than you think in all the applications, all the use cases, the way you get to your work, to your job, the way you communicate, to the basic security, as we see in the east of Europe. And it's closer than you think in terms of engagement and getting you involved in space. I did not study space engineering. I studied political science, but even for humanities, space is accessible. And it's also closer than you think in terms of Europe being a geopolitical actor in space, having its own lunar settlements and missions to the moon. So just stay close to space.
And with this, I would like to thank you all for your interest and for being here today. I would like to thank your hosts and above all to our speakers. I do hope that you felt inspired tonight. I learned a few things. Also, I work in space for almost 11 years. So thank you so much. Thank you so much for your interest in these topics, for being here, for listening, for asking questions. And of course, our speakers will still be here around a bit longer. So if you have any other questions that you would like to address with them, please feel free. And I do hope that you enjoy your evening. And I do hope to see you in 1 year again to another discussion on a Science Café about space. So thank you so much and have a nice evening.
Good evening once again. I will be very short. From the Czech Center Brussels side, I would like to thank both our speakers, Lucien and Petr, and our moderator, Vera, who we can always count on when it comes to an Earth-related topic. And if you accidentally happen to be into not just Earth observation, but also documentary film, I would like to invite you to the closing ceremony of Jihlava International Documentary Film Festival that takes place next Thursday here at Prague House. Thank you all for your questions and for coming.
And last but not least, I would like to thank
to all members of our 4 teams. Thank you very much. And also today we have one specialty, maybe you already saw it, Temná lóna, which is lightning in the garden behind you. It's the masterpiece of design studio Vizuálové and Brno Observatory in the South Moravian region. You can also come closer and see the light smoke around the Earth and also aurora, but please do not touch it. And I would like to also invite you downstairs where you can try our South Moravian wine. And also, because it's still February, you can also taste non-alcoholic wine. So, cheers. Thank you very much.